Find all asymptotes of the function f of x equals the quantity x squared minus 25 in the numerator, x cubed minus 6x squared plus 5x quantity in the denominator. The first thing we want to do is to factor this out completely. In the numerator, x squared minus 25 can be factored at x minus 5 times x plus 5. In the denominator, there is a factor of x in each of the terms, so we would factor out x to obtain x times the quantity x squared minus 6x plus 5. But we can factor this further, x minus 5, x plus 5 in the numerator. In the denominator, the trinomial x squared minus 6x plus 5 can be factored at x minus 5 times x minus 1. Don't forget to double check it. X times x is x squared, x times negative 1 is negative 1x, minus 5 times x is negative 5x, negative 5x plus negative 1x is negative 6x, and negative 5 times negative 1 is positive 5. There are three factors in the denominator. The 0 in the denominators is x equals 0, x equals 5, x equals 1, but that doesn't mean that we would have three vertical asymptotes, and that is because we see that the factor x minus 5 is the same as on top and the bottom, so we would cancel this out, and so we obtain x plus 5 over x times x minus 1. We cannot cancel anything further, so we can say that the vertical asymptote in the denominator where the 0 is x equals 0 and x equals 1. For the horizontal asymptote, we see that the degree in the numerator is 2 and the degree in the denominator is 3. That means in the long run, the horizontal asymptote is y equals 0. And again, with the leading term in the numerator over the leading term in the denominator, we see that this simplifies to 1 over x. At x gets very large, 1 over x approach 0, and that y approaching 0 will give us the horizontal asymptote y equals 0. And so there is one horizontal asymptote and two vertical asymptotes in this case. What happened to x equals 5? When we graph this function, we have to be mindful that the function is not defined at x equals 5. And so at x equals 5, there will be a hole.